Okay. Note page 172 from the solutions unit, taking a look at mixtures and their classifications. So a mixture contains many different types of molecules. And the way that we classify mixtures is based on the distribution of those different types of molecules within the sample. So two major categories. We could have a homogeneous mixture or a heterogeneous mixture. Homogeneous, prefix HOMO, you have learned to associate with the idea of being the same. So in this case, if it's a homogeneous, that means that the particles have the same type of distribution. Take a look at the picture below. The blue and green spheres seem to be uniformly distributed throughout the sample. On the other hand, we have a heterogeneous mixture. Its prefix HETERO we have associated with the idea of being different. So in this idea, the difference is referred to as different distribution. Take a look at the picture. The blue and green spheres in this picture, they are not uniformly distributed, and we see differences in where they are in the sample. Okay, so let's take a little bit deeper look at homogeneous mixture general characteristics. So if it's a homogeneous mixture, be able to explain that it has a uniform distribution, meaning the sample looks the same throughout. And if the sample looks the same throughout, we could say that the sample's composition is uniform. If the composition seems to be uniform, that means that we cannot visually see any layers or differences within the sample. Another unique idea about homogeneous mixtures is that they cannot be filtered to separate the components. We have to use other techniques. So a simple technique to separate the components of a homogeneous mixture would be to heat to boil off a liquid portion of the mixture, or if time allows, simply allow the liquid portion to evaporate. And this will separate the liquid portion from any solid portion. Another interesting fact for homogeneous mixtures, that if you put a light source up to a homogeneous mixture, the light passes through the sample as if it's not there. Take a look at the picture below. There's two containers and there's a light source, a flashlight. If you take a look at the container closest to the flashlight, you can see that the light passes through as if the homogeneous mixture is not even present. So when the light passes through a homogeneous mixture, there is no Tyndall effect observed. Tyndall effect means scattering of light. So homogeneous mixtures, HOMO, if a sample is described as being a homogeneous mixture, you need to learn this vocab word. So if it's described as a solution, it is automatically a homogeneous mixture. So all solutions are homogeneous, uniform distribution. Three major categories of homogeneous mixtures: aqueous, alloy, tincture. If it's an aqueous solution, that means it is a water-based solution. If it's an alloy homogeneous mixture, it's a metal-based solution. Tincture, funny word, but if it's described as a tincture, then this means it's an alcohol-based solution. Let's take a little bit deeper look at the characteristics of the average heterogeneous mixture. So if it's heterogeneous, there are differences. That means it lacks a uniform distribution. The sample is definitely not the same throughout the sample because the composition varies within the sample. And because the composition varies within the sample, typically we are able to visually detect or visually see layers or differences within the sample. Because there are differences due to particle sizes, usually some really tiny particles and then larger particles, which makes it hard to create a uniform composition, we can typically filter to separate the components of a heterogeneous mixture. Big clue that the sample is a heterogeneous mixture if you must shake it or stir it before you use it. Now, interesting fact about light with heterogeneous mixtures, because the particles are becoming larger, light is actually scatters through the sample. So take a look at the picture below. You have the light source and the container farthest from the light source. It looks as if it is glowing or all lit up. That's because we are observing the Tyndall effect, that the particles within this mixture are actually large enough to scatter the light within the sample instead of allowing the light to pass through. Now there are subcategories of heterogeneous mixtures. So hetero, H-E-T-R-O, differences. If you see the word colloid, that means it's a heterogeneous mixture. Examples of colloids, there's lots of them, but if you have a solid blended with a liquid, it's probably a colloid, and great examples would be paint or milk. Another type of colloid is when a liquid is blended with a gas, creating something like hairspray. So hairspray is another colloid. Another type of heterogeneous mixture, they are referred to as being suspensions. These particles are some of the particles are really large, that you can actually see some of these particles with your eyes. Great example of a suspension would be Italian salad dressing. Definitely need to shake it before you use it.